this unit is to talk about the external hardware of a computer, and this is the stuff that you can physically touch and you're not reaching inside the computer for. It's stuff that we're in most contact with. So we're going to talk about a number of different components, and it's going to be brief in terms of how much detail we go into these. We're going to talk about whether they're input devices, output devices, or anything in between. So the keyboard and mouse. These are obviously input devices. And what I mean by that is when you type a key on a keyboard, the key that you just typed is data for the computer, so it goes into the computer. We interact with it and it sends data into the computer. Same with a mouse. A mouse is an input device and it sends both positional data as well as click data. So it knows where the mouse is currently on the screen as well as what button was clicked and when it was clicked. So a device uses for interaction between the user and computer. So keyboards are input devices. They've been in use since about the 1960s. Mice have been around since the 70s. But these components have not really changed in all that time, and you're talking like over 50 years. They're basically the same. Yeah, you can say that, yeah, there's hardcore gaming mice and stuff like that, but they're still basically the same. They haven't really changed all that much. When you think about, if you compare them against like video game controllers or something like that, and how much they've evolved from the old school Atari joystick to today's modern, whether that's like the Oculus touch controls or something like that, or even a standard like PlayStation 4 or Xbox One controller. They haven't seen much change, and that is probably going to be altered soon. The way that we interact with our computers is changing because of mobile devices and whatnot, whether that's touch screens or however you want to deal with it. We are seeing differences, and they're going to start to become more and more evident as time goes on. So your monitor or your screen, this is just an output device, unless of course you have a touch screen monitor, but let's just assume it's just a regular monitor. Now this is a device used to display the visual data coming from the graphics card, so it's coming out to the user. So it's an output device. So it takes image data from that graphics card, and that graphics card basically tells it how to color each individual pixel. So depending on the type of monitor, this is done in different ways. Old school cathode ray tube monitors or CRT monitors, they used to use like a phosphorescent screen that would glow based on the electrons hitting them and whatnot. LCD uses the liquid crystal display, and it basically changes how the crystals are formed and what color comes through. Organic LED or OLED, retina laser displays, these are very similar, and they're very thin tech, but they work very similar to LCDs in terms of lighting up the individual pixels. It's just more the backlighting and whatnot that occurs, and how well spread out that lighting is. For the most part, there are other things as well. So the computer monitor has heavily evolved over the years. In the original days, it was just like a green monochrome screen, and nowadays we have 4K or 8K monitors that can produce millions or billions of colors at a single time. And they have all sorts of other bells and whistles. Some of them are even curved, and they're evolving as well. Eventually you're going to look at a point where you're not even going to be having a monitor. It might just be a projection of some kind. Who knows? So a touch screen, this is a monitor that you can actually interact with. So this is both an input and output device, so it does everything a monitor does, but it also can collect the same information that a mouse can, positional and click data. So it performs it's like a combination between the two. Now, many touch devices that use capacitive displays, typically they are going to be able to recognize more than one touch at a given time. So for example, the Microsoft Surface and the iPad, they can handle up to 10 points of contact at once, so all 10 of your fingers. These devices aren't new though. Touch screens have been around for almost as long as screens have been around, and they used to use things like light pens and whatnot, but they've become a lot more popular and a lot more advanced since the advent of the iPad. And the iPad is not the first tablet, by the way. It's not even close. Tablets were out a decade before that, even more. It's just Apple was very capable at branding it in a way that appealed to users and put it in a nice package, which was good. Printers. This is an output device. It takes data from the computer, brings it out to the user in a hard copy form. So instead of the soft digital copy, we have a hard copy, something we can physically touch and see. And again, this could be an image data. Well, it's definitely image data. Even a Word document comes out as an image through the printer. So it's sent again through the same scenario that a screen does. It gets that image data, translates it into something, then prints it out using whatever type of printing mechanism that printer is using. Whether that's like an old school dot matrix printer or it's a modern laser printer, depending on what you're using. Speakers, again, output device. Sound data coming out to the user. And this is taking data from the sound card and it's recreating the different pitches and everything like that, so we can get some beautiful, beautiful sounds. They're not always standalone devices. A lot of times they're built right into the monitors. Sometimes they can be substituted for headphones. It depends on what you're using your sound card for. Or sorry, not your sound card, your speakers for. Microphone. What I'm talking into right now. This is a capturing input device. It's capturing my voice as we speak right now, or as I speak, and it's translating it through the sound card into those ones and zeros so the computer can deal with it in whatever way it needs to. So whatever software. So for right now, I'm using Snagit to capture this video, which means all my audio data is being sent directly to Snagit, and then Snagit is handling it and by recording it and syncing it up with the video that I'm making. But there's other software as well that uses microphone, things like Skype, video games, all sorts of different things. Camera, or a webcam, depending on what you want to call it. A lot of times in laptops, these are built right in. Not necessarily in desktops, but that's not to say you can't buy one. And again, this is for capturing input and using it in various programs like Skype or whatnot. And a lot of YouTubers will capture their own face. I don't think you need to see me in these videos. I think the data is a little bit more important, but if I wanted to, I could hook up a camera so you could actually see me talking as I go, me frantically using my hands because I like to talk with my hands, that kind of thing. So they've seen a massive increase in quality over the past decade. It used to be in the early 2000s where everything was very, very clunky, very low frame rate, like 5 or 6 frames per second, just terrible. Modern Skype phone calls can go as fast as 60 FPS or even more. It all depends on the software you're using and how fast your bandwidth connection is. So it's not necessarily a limitation on the camera, but it's a limitation on how much data can be passed over the network. Flash drive or USB key or thumb drive, so many different things. These are permanent storage devices, but ironically they use much of the same technology RAM does. But RAM is volatile. RAM requires power. How does that actually work? Well, it uses something called a capacitor. And the capacitor basically holds a temporary charge and releases that charge slowly over time, keeping it constantly with enough energy or enough electricity going through the system to maintain the data. And it kind of recharges itself every time you plug it in. But it does have a shelf life. Eventually, that USB flash drive is going to fail on you in approximately 7 years' time, as long as it's treated well. Less if it's not treated well. Old school video games used to use these things, backup batteries and whatnot, and what would happen is like the whole game itself would be basically stored on flash RAM. And then once they started to be able to save data, they used to have a backup battery which allowed us to save our progress or whatnot in our games. Nowadays, those backup batteries are starting to die, and people are losing. You can't save your game anymore when you go to play any of these old school RPGs. Not that too many of you are. But basically, a flash drive is just RAM stuck in a little thumb drive. So the modem. So this is both an input and an output device. It's not inside your computer. It's what the NIC card connects to. So this one is taking and giving data to the network. So data used to send and receive data across a network of some kind. The data is broken up into small chunks called little packets. Think of it like this. If you wanted to give an entire bag of sugar to your neighbor, but you couldn't carry the whole bag, you break it up into little baggies or even sugar packets, and you sent them all over one at a time. But they're numbered. And they're numbered because maybe they need to be sorted. But you're losing, let's say your neighbor gets all these, but they're missing little packet 5 and 7. So they'll yell over, "Hey, I didn't get 5 and 7. Can you resend those?" That's basically the way it works. It expects certain number data. If it's missing some, it calls back and says, "Hey, can you resend those things?" And that's how it actually happens. Two. I digress a little bit. So data is sent along the network through the various mediums such as physical connections like your blue Ethernet cable, fiber optic connections, wireless connections, Bluetooth connections, all sorts of different ways that data can actually be sent. So here's a quick question for you. What do you think the primary method for internet to travel around the world is? Say, for example, to get from America to Europe. How's it going to cross that ocean? Do 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 do. Time's up. Anyways, it actually uses underwater cables, big, giant, thick cables. So it's a physical connection. Problems with satellites and things like that is they're super slow. Can you imagine if everybody in Europe was trying to talk to America and they had to go through satellites? We'd never be able to communicate with them. So it actually travels in underwater cables. So how does it all work together? Pardon the formatting. So let's try a quick little example and try and follow the path. Whenever you see one of the arrows, think of that as data traveling from point A to B. It's on the bus. Okay? So let's say we want to send an email to a friend and they read their email through Gmail, an online client. So as we're typing that email, for every single key that's hit, we touch the keyboard. That key is then sent to the CPU. The CPU stores it in RAM. The RAM sends it back to the CPU, which then sends it to the browser, which then comes back to the CPU, which then sends it to the graphics card. Remember, the CPU is kind of like a governing tool, right? And then the graphics card sends it directly to the monitor. Great. Now when we've finished typing our email and we click send, we click on the mouse, and that positional data goes to the CPU, which then sends it off to the software that's currently running, your email client, which comes back to the CPU again, and sends it off to your network interface card, which will eventually travel through the internet. So the message traveling, it goes from the NIC card to the modem to the internet to Gmail's NIC card and their server somewhere. So their Gmail server CPU. And then it gets stored in the RAM, and then back to the CPU, and then it goes to the hard drive for long-term storage. So when that person goes to access their email, they're going to access that hard drive on Gmail server. So that's the basics for the interactions between the components. So let's just talk quickly about some basic hardware software maintenance. Oftentimes your OS's performance relies heavily on the maintenance of your hard drive, making sure that everything is stored effectively. Now, in the previous lessons we talked about how data on a hard drive is stored sequentially, which means all the pieces of information for a given file are right beside each other. Now let's say, for example, you had a hard drive that was starting to fill up, but you deleted a few files randomly from your computer. You just didn't want them anymore. You didn't need them anymore. What happens is that can cause certain problems. So looking at this, let's assume this is your hard drive, and everything is stored in a nice sequential order. Each color is a different file, and X means X with a square in it means it's unused. So these last four elements are completely unused. All other colors are used up by a file. Now imagine we wanted to delete something. Imagine we wanted to delete the green one. What actually just happened? So we have blue, red, black, nothing, yellow, nothing. Huh. Now you think about this, what just happened is we just introduced a gap. And that is wasted time. It's wasted time because the disk has to keep spinning. Remember, this is a hard drive. So the disk is spinning around, and when it wants to get to the yellow, and it's currently on the red, for example, it's got to wait for all of this data to pass, then all of this nothing data to pass, till it gets to the yellow. We need to get rid of that gap. That gap needs to be pushed to the other side. So what we've done is we've fragmented our hard drive. We've got fragments everywhere. There's a tool built into Windows called a defragmenter, and what it'll do is it'll remove the gaps and put it at the end. It'll literally shift all these things over so everything is in a nice sequence, so we waste a lot less time going from A to B when we're trying to access certain files. So we end up with a system more like this. Now, defragmenters are not mandatory. They won't automatically happen. You have to either manually do it yourself, or you must set up your computer to do it every so often. You actually should do it fairly frequently, because every time you delete something, it's creating a gap. The thing doesn't just fix itself for the most part. So that is all of our external components and maintaining our computers. Next up, we're going to talk about your first, or we're going to talk about your hardware software assignment.